Innovation is important, but it's nice when we find out that some of the existing technology has stood the test of time. The partition and volume options on Windows Server are one thing that has remained constant. Every hard disk has 3 layers of preparation, and this model has been intact for as long as I can remember. The first layer is the type of partition table. Traditionally, a master boot record has held this table, and the BIOS of a computer was designed to read this table to find system partitions. Well, BIOS on computers is being upgraded and ultimately replaced by a technology that supports bigger hard drives, faster boot times, and overall better hardware integration. UEFI is that new technology, and new hard drive partition tables have evolved along with it. The GUI ID partition table, or GPT configuration, is the default setting for a Windows 2019 server. Once we have a partition table in place, the second layer in the Windows Server preparation of a hard drive is specifying the type of disk. When you complete a traditional install, Windows lays out a physical disk with GPT and basic disk configuration. Basic disks are divided into partitions that can be formatted and mounted with drive letters or other types of mount points. With GPT, a basic disk can be set up to hold as many as 128 partitions on a single hard drive. The primary difference between partitions on a basic disk and volumes on a dynamic disk is the range of options that you have when setting them up. Partitions can be resized up or down even after they've been created and filled with content, and this is easily done from Disk Management or from the Windows Administration Center. However, if you want more flexibility, more redundancy, more performance benefits, you're going to need to look at dynamic disk and creating different types of volumes. Let's go ahead and check out what that looks like. Now, I've created a whole nother domain of demo machines because we've played around with several different features in the earlier videos of this course. Right now, we have an environment with a domain controller and 2 servers joined to that domain. This server, Server 1, is installed with Windows Server 2019 Data Center, but what we're going to look at is the same in Standard Edition and even in Essentials. I'm going to open up the traditional Disk Manager. You can get there by right-clicking on the Start menu and finding Disk Management in that list. Much like the design of partitions and volumes themselves, this tool has been with us for quite some time. You can see that this server was installed with 2 hard drives, each one roughly 128 gig in size. And when I installed this server, I accepted defaults, so it took all of the available space on the first hard drive to create the volume to install Windows. This is where my boot files are located. This is where the operating system is located. Currently, this is where everything, except for recovery information, is located, and it's taking up the entire disk. If I wanted to reduce this, I could do that from right here. I can right-click on that volume that's currently taking 127 and almost a half gig in space. I could right-click on that and choose to shrink the volume. It's taking up the entire space, so I don't have the ability to grow the volume, but I can shrink it. And this is a pretty straightforward and simple process to complete. It calculates how much room there is on the drive, how much space I have to play with, and the question it asks me is not, how big should this partition be when you're done? The question is, how much do you want to trim off? It's going to allow me to trim off as much as 120 gig. Well, I don't want to take it down that far. I still want about 64 gig to play with on this volume. So I'm going to cut this down by, let's go with 60 gigabytes. It's asking me to give the information in meg, and I'm going to just round, and let's go with 60,000. And I can go ahead and shrink that volume. And you can see that that happens pretty quickly. Now I'm going to right-click on that volume again, and we can see some other options in here. We can shrink the volume again, or we could actually grow it. We could extend it, and I'm given the option to add a mirror. But there's a catch here. I really can't. I can't add a mirror to this because it's a basic disk. If I want the option to create a mirrored set, or to even create striped sets for performance, I need to change this drive from basic to dynamic. And that's not a difficult change to make either. It does technically carry some risk. I've never had anything go wrong, but we are changing the layout of the hard drive, so I need to go on record as saying there is some risk here. If I want more flexibility in how these drives are set up, I can right-click on the disk, and I can choose to convert it to dynamic disk. And I have the option to go ahead and convert everything to dynamic disk at this time, and I'm going to take that option and go ahead and click OK. It will verify that that's what I want to do, and I'm going to go ahead and say yes. And once this is done, I'm going to reboot. I have a caution here that if I have a multi-boot environment or some other situations, there may be some changes that'll be hard to recover from. But I'm running one operating system on one server. Most of the concerns really don't apply to me, so I'm going to go ahead and say, yes, I want to convert to dynamic disks. Now, it didn't prompt me to reboot, and it's possible that I could go on and be just fine. However, there are some system configuration changes that are worth manually rebooting the machine, even if it doesn't require it. One of the things that I'm going to do first, however, is create a mirrored set. Now that I have dynamic disks, I can take the system partition, right-click, and choose to add a mirror to it. And I can tell it which physical disk needs to hold the replica, the copy. So I'm going to select that, and when I click Add Mirror, it will go ahead and create the redundant volume and start copying the information over. And it may take some time to complete, but once the status changes from resyncing to healthy, that would be a good opportunity to go ahead and reboot the server and allow it to come up fresh and clean with the new configuration. Any new volume that I create, anything that's not the operating system, has options beyond simply mirroring. If I were to right-click in this unallocated space, I could choose to set up a striped set. If I had at least 3 physical disks, I could create a new RAID 5 volume. These software RAID arrays are available to you if you're using dynamic disk. Many production servers use hardware solutions to manage this kind of redundancy, and data centers with large numbers of virtual servers often store virtual hard drives in various types of high availability storage solutions. But these volume options still exist at the operating system in Windows Server 2019, just like they have for the last couple of decades. Once a hard drive has been installed, initialized, and partitions or volumes created, the next decision that you have to make is regarding the file system that you're going to apply to that volume. Now, NTFS has been the preferred file system for years because it allowed for more specific security settings, not just on folders, but on individual files. And it allowed you to manage storage space by configuring quotas. On top of that, it allowed you to create larger volumes and larger files within those volumes. But these comparisons were against the file allocation table, the traditional FAT file system. And given these comparisons, the NTFS environment was the obvious choice. FAT, followed by VFAT to support long file names, and FAT32 to support somewhat larger volumes, hasn't really changed that much over the years. The primary advantage of FAT is that this file system can be read by pretty much any other platform or application. But that isn't always necessary, and it isn't always a benefit. During normal operation, I want the Windows Server operating system to read the file system and serve up the data to other apps and systems on my terms. I don't always want other platforms browsing the local storage. When we look at capacity, the FAT file system had some pretty restrictive limits, the maximum volume size being 32 gig in size, the maximum file being 4 gig in size. Several DVD images are already larger than that, so if you're storing install media, that 4 gig limitation can already be too much for you. But you do have the compatibility that we talked about. NTFS in Windows Server 2019 supports volumes that are up to 256 terabytes in size, and individual files that are just as large, although that one is currently just theoretical. It does remain the most robust file system in terms of security options and other features, but this big long list of features may not always be what you're looking for. The Resilient File System, or REFS, was introduced in Windows Server 2012. On its face, it would appear that REFS has all of the same capabilities as NTFS. In fact, in terms of these metrics, it hardly seems worth introducing a new file system at all. But among the benefits of the original version of REFS was that it didn't carry all of the overhead of NTFS, overhead that will affect performance. What it does offer you is the ability to detect file corruption and the ability to restore to a small degree and remain online while dealing with corrupted data. Some server applications, say for example Exchange, has its own storage management features. It doesn't need all of the quotas, all of the features that NTFS has offered. Things like keeping the volume available even through small issues is going to be more important, and leaving room for Exchange to manage its own database makes REFS, with its lower performance overhead, a preferred environment. With REFS, you gave up the features you didn't need and created an optimal environment for these applications that manage their own data. In later versions of REFS, you began to pick up many of the same management tools that you have in NTFS, but you still have the performance benefits. Some are suggesting that REFS will overtake NTFS completely, but I still think they each have their place. The full complement of features in NTFS still make it a good solution for the Windows boot volume and for the average file server. I'm showing here a Windows server that has two volumes that were created at exactly the same size, capacity of 29.2 gig. The one on the left was formatted using NTFS, the one on the right was formatted using REFS. And you can see some of the differences from right here. You can see that in NTFS, we have a quota tab that doesn't exist in the Resilient File System. However, when you look at the amount of used space, these are empty volumes. I haven't copied any content onto these. NTFS is using 73, almost 74 meg to store the information that it needs to keep the volume alive, even as an empty volume. REFS is using over a gig for those same purposes. The capabilities of REFS will take up a little bit of drive space to maintain, but they're worth it in the performance benefits later on. Also, look down at the bottom. In NTFS, there's a checkbox to compress all files on the volume, and this may or may not be a feature that you want to see. There are some concerns and there are performance hits over it, but it's an available option nonetheless, an option that doesn't exist in REFS. As we go forward, we're going to take a look at one of the features that REFS has picked up that allows you to manage space without the risks and performance hits of compression. Hard drive space is relatively cheap, but that doesn't mean you should take it for granted. It's still worthwhile to make sure that you're using your hard drive space wisely. It used to be that you would deal with vanishing storage space in one of three ways. You could implement user quotas to manage how much one person is allowed to save. You could add new drives to the server. Or you could compress a volume. This third volume has always been a last result because it kills performance. The process of packing up files and unpacking them again introduced a performance hit as well as a risk of corruption or loss. Now there's a new option, data deduplication. It allows you to save space as you store and access files without the risk or performance hit that comes from compression. The basic idea is this. Information is stored in blocks of varying size on your hard drive. With data deduplication, blocks are identified that are exactly the same. Redundant copies are removed and replaced with pointers to where that information can be stored only once. There are 3 different workloads where this can really make a difference. A general-purpose file server is likely to contain a bit of redundancy. Think about how many of your users store files made from the same template. There's a block of that file that is identical in all of the saved iterations of that document. A backup target is an even more likely candidate for deduplication. Think about last week's backup and this week's backup. How much is exactly the same? If that redundant information could be stored once, but accessed uniquely for each backup set, how much space could that save? The third workload is a virtual desktop deployment. If you're running your own desktop as a service environment, you have several remote desktop environments that are essentially copies of the same virtual hard drive. Think of the space saving if you didn't have to have all of that identical information saved multiple times. This is a feature that we can make available on NTFS and REFS volumes. Here we are back on the server we've been looking at in this chapter, and on our NTFS volume and our REFS volume, I've stored a folder called Music. Now this folder is identical in both locations. Here it is on the NTFS drive. It has 1,243 files. Here it is on the REFS drive. It is the same folder with the same amount of files. Each of these folders contains my music collection. Whole lot of files, none of them exist more than once within a folder. So let's see what deduplication can do for us. First, we need to add it, and data deduplication is a role. So let me go ahead and go to the Server Manager to go ahead and install that. Looks like the progress bar is done, so let me select to add roles and features. Move forward through this process that we've seen a few times. Now here we are. Inside the list of server roles, I need to find File and Storage Services. And you can see that one of these components has already been installed. Let me go ahead and expand that. Inside File and iSCSI Services, if we look down the list just a little bit, there is data deduplication. Now there's nothing extra to be added, so let me go ahead and choose this and move forward. I'm just going to accept defaults and allow this installation to run. All right, it looks like our installation is complete. So let me go ahead and close this, and I'm going to close these folder properties as well. We don't need those anymore. Here in the Server Manager, I can go to the File and Storage Services tab. We can take a look at the different volumes on our server. Data deduplication is turned on at the volume level, not the folder level, so we need to manage this one volume at a time. From this pane, I can right-click on a volume and choose to configure data deduplication. There isn't a lot to configure here. From this top drop-down box, I can choose which of the 3 workload scenarios is best suited for my needs. This is a file server, so let me go ahead and choose that. If there were files that I wanted to exclude from the data deduplication, I could specify them by extension here, or I could add specific folders that would be removed from the deduplication. This Set Data Deduplication Schedule button would allow us to schedule this to happen at times when it won't disrupt normal workflows. Having this process run overnight is not a bad idea. Well, after I apply this and accept this and move on and do the same for the REFS volume, configure data deduplication, for a general purpose file server. Apply that and set OK. I have now enabled the service. Since I didn't schedule it, I need to go ahead and run a job manually. I'm going to go ahead and open PowerShell as an administrator. And from here, I'm going to run the command start dedupe job. And there are only a couple of parameters that I need to specify. The first is the type of deduplication job, which is optimization. And I need to specify which volume I want to remove duplicated data from. And there's one more parameter that I'm going to use just for this demonstration. I'm going to set the priority to high. You wouldn't do that on a production server during the workday because that will take away performance from other things this server might want to do. But in this demonstration, and in your test environments, if you're not doing anything else with the server, that will allow this to run more quickly. Now I'm going to go ahead and hit start, and that will take a while to run. So you would likely schedule this optimization during off hours. But you can take a look at the status at any time by running get dedupe status. And as time moves along, you can see how things are going, how much space has been saved, how many files have been condensed, and which volumes are involved in this savings. Data deduplication may not be the right fit for all volumes and all workloads. It can get in the way of how databases and other applications try to manage their own data, but it is preferred over compression or simply adding drives until you run out of bays. I wanted to be sure and include a section on a feature that was introduced in Windows Server 2016, but has not been present in the semi-annual releases of Server in 2017 or 18. I was really glad to see Storage Spaces Direct included in Windows Server 2019 once again. At its core, S2D is a clustering of hard drives. Large environments need to use lots of servers to create highly available, redundant, and fast solutions for computing, network, and storage. And you may recall earlier in this course, I mentioned that Storage Spaces Direct with Hyper-V combined to create a hyper-converged infrastructure. S2D is the storage component of that equation. But I may be getting ahead of myself. Let me back up and describe what Storage Spaces Direct is and what it does. Storage Spaces Direct allows you to cluster multiple servers specifically for storage purposes. Let's say these 3 Data Center Edition servers have the failover clustering role and the Hyper-V role installed. These 3 servers each have multiple physical drives, which can be clustered using the failover clustering role, and then enabling Cluster Storage Spaces Direct will make all of those drives function as a single storage pool. That will allow you to create volumes in that pool and format these volumes using the Cluster Shared Volume File System. That provides 2 benefits. First, the volumes appear and function as if they were local to every server node in the cluster. Second, the volumes are resilient. That's one of the keys behind any type of cluster. A hard drive or a physical server may die, but the volumes stay online as if nothing happened. This is the kind of thing you would expect from a hyper-converged infrastructure or from a high-end storage management solution. But these features are not third-party, they're not extra, they're not even System Center, they're built right into Windows Server 2019. No third-party applications, no special requirements from hardware vendors. Now, let's take a look at what happens when we put this to work. Let's say each server in the cluster is running virtual servers for various production tasks. One of our virtual machines is configured on server 1, and the virtual hard disk file is saved on the S2D volume. The volume makes the VHD file appear local to server 1, And it's entirely possible that the working copy might be there. But here's the cool part. Let's say the hard drive controller in server 1 decides to take a break, and all of those drives are suddenly offline. This storage cluster has all the hard drives in their current state running in the cluster, replicated across multiple drives. If the virtual machine is configured to point to a VHD file in the cluster, the virtual server never goes offline. So now virtual machines can migrate over virtual networks using storage managed in an S2D cluster, and it really does encompass all three elements of hyper-converged infrastructure. Storage Spaces Direct is a very robust storage solution, but not all environments need something that's that intensive. Networks that don't have large data centers still need reliable and often redundant data for high availability. Often, however, a simple solution will do the trick. Storage Replica is a feature that you can add to a Windows 2019 server, Data Center Edition, or Standard. That's a change from Windows Server 2016. In Windows Server 2019, a data center server can replicate as many volumes as it likes to other servers in the domain. A Standard Edition server can still replicate one volume from that server to another location. Let's walk through the requirements and how to set up Storage Replica within our network. Here you can see I'm on my Windows 10 workstation. I'm starting here because I'd like to use the Windows Admin Center to do this work. And as we've demonstrated before, the Windows Admin Center can be installed and used from a workstation in the domain just fine. So here I am in my domain. I have my workstation. I also have 3 servers, the domain controller and 2 file servers. Let me go ahead and take a look at server 1. Storage Replica needs to have a source and a target for the replica, and neither one can be a domain controller. So here we have a basic file sharing server. Server 1, if I scroll down and look at storage, one of the things I will look for is the volumes created on that machine. Let me look and see what's on disk 2. And here I have 2 volumes that are exactly 30 gig in size. That size is going to be important. In fact, let me go ahead and open another server in a new tab. In this new tab, let's go ahead and open server 2 and take a look at that storage configuration as well. I scroll down to storage, and I take a look at disk 2 in this server. We can see that it also has 2 volumes that are exactly 30 gig in size. Now, there's nothing special about the 30 gig size. What is important is that the sizes match exactly from one server to another. The R, or the replicate volume, I chose that letter just to be simple here, is exactly 30 gig in size and uses the NTFS file system. On server 1, I have an R volume that is also exactly 30 gig in size. That matching of the volume to be replicated is critical. We can start the process to do a replication, but Windows will check, and if the sizes don't match, the replica will fail. A second volume is needed for a replica, and it doesn't have to be as large, but it also needs to match exactly in size from one server to the other. Here I've created an L volume, L for log, and it is exactly 30 gig in size on server 1. And on server 2, I have a log volume that is also exactly 30 gig in size. That's the first requirement. We need the volume to be replicated on both servers that's exactly the same size, and we need a log volume that will not be used for anything else that's also exactly the same size on both servers. With that in place, the next thing we need to do is look at the roles and features that are installed on both servers. Here on server 2, let's take a look at the installed roles and features, and we're looking for a feature, so I'm going to go ahead and collapse the roles, and scroll down through features until we get to Storage Replica, and we can see that that role's been installed. If it wasn't yet, I could check the box and install it from here. Let's go ahead and check Server 1 as well. Roles and features. Go ahead and collapse the roles and scroll down through the alphabetic list of features to Storage Replica, and it's installed. Those are your requirements. You need this feature to be installed on both servers, and you have to have volumes that are identical in size from one server to the next. Here in the Windows Admin Center, we now have a new tool, and this is recently added. The Storage Replica option can be selected from the left, and we see that there are currently no partnerships, but we can create one. As we select New Partnerships, we get a dialog off to the right where we start by entering the source computer name, and it's going to look up this server as we type it, so keep typing until you get to the end of the fully qualified domain name. This is server01.landonhotel.com, and it's checking that server out to make sure that it meets the requirements. It does meet the requirements, and here it's selected a source volume and a log volume. If it picked them incorrectly, we could use these drop-downs and change them. But we do need to assign this replication group a name. This is a name for the source replication group. If you're using Standard Edition and only one server, then it may not feel like this name is all that important. But if you're going to use Data Center Edition servers and create multiple replication groups, it will be important to give these replication groups names that make sense. I'm going to go with simple names just to save time on typing, and just call this one Source. And then under Destination, I can go ahead and pick the computer name that will receive this replication. srvo2.landonhotel.com. And you may have noticed that it was looking for the server name while I was typing. It tried to find it before I was done and wasn't able to find a server with the incomplete name. But with the correct name in place, it found it, it meets the requirements, and we have, once again, the destination volume and destination log have been selected. We could change those if it had chosen incorrectly. And we need to give the destination group a name as well. I'm going to call it Target, mostly because Target is shorter to type than destination. That's all the information we need. I can go ahead and create this new partnership. It will verify both machines and start replicating data from the source machine so that we will then have 2 full working copies of all of our data. I have a notification up here. Let's see what it says. New partnership creation in process. Once that's done, I'll get a new notification saying that the partnership is complete and that the replication has begun. These replications will copy an entire volume. If you have multiple shares, multiple directories on there, the entire volume will be replicated from one place to another. That's important to keep track of. If you're doing this over a long distance, there may be some latency, and some files may take a moment to be exactly the same between the multiple locations. It will, however, synchronize much faster than the old DFS folder replication that was often several hours or even a couple of days behind. Here you can see that the new partnership was created, so let me close my notifications, and we can see that this synchronization is now underway. I can click here for the status, and down below I could look up any information, but I can see what I need right here up top. There is 1.5 gig copied so far out of a 30 gig space, so we're in the process of the initial replication. You can use this service as part of a disaster recovery plan to maintain data in 2 separate locations in case of catastrophe, especially in environments small enough that more intensive clustering just isn't practical. The last 2 videos focused on high availability features in Windows Server, features that help you recover from unforeseen catastrophes, the cluster options of Storage Spaces Direct, and the simple redundancy of storage replica are great safety measures to have in place. But not all workload migrations are emergencies. Sometimes it's just time to move a workload to a new server. Migrating many of the roles and features can be done using SMIG tools or their own unique processes designed to move the entire configuration from one place to another. But file servers can be a different animal. If you have an old file server that needs to be retired, you're probably dreading the task ahead of you. Copying files from one place to another, that's easy enough. But to really migrate that workload, you have to find a way to copy file permissions and share permissions, create the new shares, and set the quotas and encryption and whatever else might be going on your old file server. I think we all understand the problem, and Microsoft has fielded questions about this issue for quite a while. They've now introduced a new feature to facilitate just this type of migration. Storage Migration Service is their answer. And this feature has 3 parts, or roles, to be played by servers in your network. The orchestrator, this is a server that has to be at least Windows Server 2019. It could be newer. It's going to take on the role of managing this migration. It could be the target or the new file server, or it could be a separate machine altogether, but it needs to be configured with the Storage Migration Service as well as the SMS proxy feature. The next server in the mix is the new file server, the destination server. This is the machine that's going to accept the migration with all of the configuration. It also needs to be Windows Server 2019 or an equivalent semi-annual release of Windows Server, and it needs to have at least the SMS proxy role installed. It doesn't need the actual SMS feature if it's not going to play the role of orchestrator as well, but it does need that SMS proxy role installed. And don't forget to plan for enough storage space to accept all of the files on the old file server and leave room for future growth. Finally, we have the source server. This is the old file server that's been doing its job for a while. The requirements here are pretty simple. It needs to be at least Windows Server 2003, and that's it. There's nothing else to install on that machine. But let's face it, if your file server is running Windows Server 2003, you've really been putting this off. Another requirement here is that all of these servers need to be part of the same Active Directory domain, and you need a domain account that is a local administrator on both the destination and the source machines. Never forget the firewall. You need to make sure that you've opened the local firewall on your target and source machines to allow SMB and NetLogon into the servers. You also need to allow in WMI and DCOM as well. Once the firewall is configured, you can add the extension to the Windows Admin Center. And this has changed since the preview. At this point, if you load the Windows Admin Center and select one of the servers involved, you can find the Storage Migration Service in the menu on the left and a really convenient install button on the right. Once that's installed, you can use the Windows Admin Center to do the migration, and it will happen in 3 phases. First, an inventory is conducted to determine what is on the source server. Second, the files are migrated, including share names and all of the details that keep most of us from doing this kind of migration. Third, the cutover phase will migrate the IP addresses and assign the destination server the computer name of the original source server. At that point, you're going to need to rename or decommission the old server. Users will be able to access the same files with the same network path and be none the wiser that you just swapped out an entire server.